In this video, we shall discuss about .NET Object Layout. First, we will start with a question. What is the minimum size of a .NET object? We know that in C++ world, the size of an object is a sum of the size of its non-static data members. But our point of interest is .NET, so consider in C# a class has been declared which doesn't have any data member. So how much size it will occupy if an object is been created in the application heap? So let's go straight forward to the answer. It would be 12 bytes in 32-bit. It will be 24 bytes in 64-bit systems. So the next question immediately arises. Why a .NET object takes this much of memory even when it doesn't contain any data member, right? Memory is precious. Why not 2 byte or 4 byte? Why it takes 12 bytes? So what does it additionally contain? In order to see that, we have to inspect the internal structure, that is .NET Object Layout. So let's see a pictorial representation. This is the pictorial representation of a .NET object, any object created on the heap. It has, by default, 3 sections, 3 blocks. Each consists of 4 bytes. So 3 sections into 4 equal to 12 bytes. Let's explore each section. The first one is header section. Header section contains the information of sync block. This I will explain during the time of threading. This contains synchronization data. But now consider it contains the header information. The next one is the middle section. It contains the operation metadata. That is the class information about the methods. Information about the method is been stored at an address, method table, and that address is been embedded into the middle section of the .NET Object Layout. This is very important concept. We will discuss in the next section that why such activity has been made, why operation metadata is been embedded to each object layout. So currently we'll go to the next section. And also we observe that the object address is pointing to the middle section. It is not pointing to the header section, right? Okay, anyway, we'll come to the data section. We know that the class doesn't have any data, still the data section exists. It doesn't contain any information. But consider one data member is been declared in the class. So that one data member's information will come to this data section. If there are 2 members, consider the class Tiger which has 2 members, then the first member comes to the default section, and for another member an additional data section has been created. So the total size of the object would be 16 byte. These 2 things we will prove in a practical demonstration. Now we will do a demo using a WinDBG and prove and show all these sections and the object layout of this particular 2 animal and tiger class. I have a demo application. I have created, applied a button, an animal and tiger object has been created. Now applications heap will have these 2 objects. Now let's go and inspect the memory. For that I have to connect the debugger to this application, attaching to the process. I am attaching this test application. Okay, the first thing I have to load a DLL called SOS, because SOS DLL contain all the .NET debugging commands to debug a .NET application using WinDBG. So this is my preliminary step. I am doing that. Now the SOS has been loaded. Now my next task is to inspect these 2 animal and tiger object. They are in the .NET memory. I wanted to get their addresses. For that I am applying a command. This command means it will print all the animal object from the memory. There is only one animal object, so it came, right? One object. We got, it is 12 bytes. We know that animal object doesn't have any data member, so it prints. Now we wanted to know the object layout, right? I am taking this particular address and I am using a dd command which will print the raw memory. Now if I am printing this memory, it will print from the middle section because object address is been pointing to a middle section. So in order to print the layout from the header section, I have to use object address -4 offset because header stays in the offset of 4. So I am doing -4. Okay. So my object having 12 bytes, so this would be the object layout of animal class. Observe, header section doesn't contain anything. I told that it doesn't have any thread synchronization, so it is empty. Second one is the middle section, which contain the metadata, I mean empty table. Just observe that this particular address EAC is the same as method table, right? So middle section contains operation metadata and it doesn't have any data member, so data section is been empty, right? So this is the animal objects object layout. Now we will go and see tiger object. According to this, the tiger class is having two data members, legs 4 and tail, the data member is value is 1. So let's inspect. The same way I am using dem heap minus tiger, right? Tiger, one object of tiger, it is 16 bytes. You know, we have already explained theoretically. Now let me print this particular thing. Copied the address, same dd command, I am using -4 to get print the full layout. Now there is no header section and this 4 bytes is this one because it is 16 byte. So this one is the middle section, which is which should be empty. Sorry, this is another one. Sorry, I am printing again tiger, right? Tiger. I am copying the tiger object. I have to do this manual error, right? So now you can see that header information 0, 38, which is nothing but the empty, and here you observe 4, which is the data section of leg, which is 1, which is the data section of what is that? Data section of tail. So this is the object layout of tiger. So in this particular example, we have theoretically explained the .NET object layout and practically showed the object layout, how it stays in the memory, right? So in the next section, we will discuss more about why this particular method operation table is been embedded into the object layout. Please listen to our other videos. We request our users to subscribe our YouTube channel, and we have also given hands-on exercises in our blog. Thank you.